Alright, now I'm going to prove that sine 2x over cosine x plus cosine 2x over sine x is equal to cosecant x. And that looks like a little bit of a mouthful, but we can do it. I hope. No, we can do it. So like I've mentioned in videos past, it's usually best to take the more complicated side and simplify it to the other side rather than trying to complicate the simple side. So it's better to go this way rather than this way. Another thing I'll note is that you'll notice this side is one single term and we have two terms here. So somewhere in our proof we're probably going to have to add these two fractions together. Okay, so I'm just giving a few hints for how we're going to work through this proof. To start, you'll remember that there are identities for cosine 2x and for sine 2x and cosine 2x. Okay, there is one very popular identity for sine 2x, but there are three relatively popular identities for cosine 2x. So in my head, it seems pretty obvious that sine 2x should be the one we should start with because there's only really one that we could replace that with. I have three options for cosine 2x, but one for sine 2x. So I'm going to make that substitution first. And then hopefully as I go through my proof, I'll see which identity I should use for cosine 2x. Okay, so to start my proof, you know what, I'm just going to box this so you can know that that's our question, the thing that we're trying to prove. So left hand side is equal to sine 2x over cosine x plus cosine 2x over sine x. I'm going to use the identity again for sine 2x that says sine 2x equals 2 cosine x, I ran out of room, 2 cosine x sine x. Okay, so I'm just going to replace this sine 2x here, this sine 2x here with this expression. Okay, so I'll do that in red so you can see what I'm doing. So this equals 2 sine x cosine x. Oh. All over cosine x still. Whoops, I did that all in red. Not all of that was substituted, just this. Plus cosine 2x over sine x. Nothing changed there. Okay. I've got a cosine x on the bottom, cosine x on the top. Those will cancel. So those will cancel each other, leaving me with just 2 sine x plus cosine 2x. And again, I'm leaving the cosine 2x alone because I'm not sure what I want to do with it yet. I'm not sure which identity I want to substitute it for. So I'm just going to wait and see what happens. Like I mentioned up here, I need to eventually add these two terms together because I only have one term over here. So I'm going to do that now. I'm going to add these two terms together. Again, 2 sine x has a denominator of 1. To get common denominators, I need to multiply this by sine x and this by sine x because I want the bottom on both of these fractions to be sine x. So I go ahead and do that. That gives me up here 2 sine x times sine x is 2 sine squared x. So 2 sine squared x over sine x plus cosine 2x over sine x. So now I have common denominators. I can add the tops together. So I now have 2 sine squared x plus cosine 2x all over sine x. Now I need to do something with this cosine 2x because there's not really anywhere else I can go except to replace this. So just as a reminder, I've got 3 options here. Okay, my first option is, sorry, I'll write that in red. My first option is cosine 2x equals cosine squared x minus sine squared x. That's option number 1. Option number 2 would be 2 cosine squared x minus 1. And option number 3 would be 1 minus 2 sine squared x. Okay, so one of these identities I'm going to use to replace this cosine 2x. And of course, you're probably wondering, well, which one do I use? Well, you could try all of them, and maybe more than one of them would work. But let's just look at what we have here. Okay, I'll zoom out a little bit. Let's look at what we have. I want to replace this, and I want to do that in such a way so that it hopefully deals with this upper term. You'll notice that in our original question, I've got cosecant x over here on the right side. And I've got a sine x down here, which is almost like cosecant x, except for the fact that I've got a bunch of junk up here. Right? So probably the identity that I'm going to use out of these 3 is going to be this one, because that has a 2 sine squared x, just like I have over here. Right? So let's see what happens when I do that. Again, sometimes, with proofs, you just have to try an idea, and if it doesn't work, you go back and try a different idea, and eventually you'll get it. But we're going to try this and see what happens. All right, so I'm going to replace this cosine 2x with 1 minus 2 sine squared x. And let's see what happens. Okay, so this equals 2 sine squared x, and then I'll do the replacement in red, plus 1 minus 2 sine squared x. And all of that is over sine x. Okay, so did that help me? Well, let's see. I've got 2 sine squared x and negative 2 sine squared x. So those are just going to equal 0. Oh, that's good. That took care of a big mess up there. So now that leaves me with 1 over sine x. And you know that cosecant x is equal to 1 over sine x. So now we are pretty well done. That is equal to the right-hand side. Okay, remember we wanted it to look like cosecant x. And we have achieved that result.